Have you ever stopped to think about what's really going on inside your phone, or your laptop, or literally any piece of modern technology? Well, it's all built from the same basic building blocks. These components are like the alphabet of a hidden language, the language of circuits. And today, we're going to learn the two most important words in that entire language.
And it all really boils down to this one simple question. Where does the energy, the juice, actually come from? In any circuit, what's the engine, and what are just the parts that the engine moves? The answer, it turns out, lies in two very different families of components.
You see, every single component you'll ever encounter in electronics fits neatly into one of two buckets. On one side, you have the passive elements. Think of these as the consumers, or maybe the managers. And on the other side, you've got the active elements. These are the providers, the source of all the power. They have completely opposite jobs, but you absolutely need both to make anything work.
All right, so let's start with the passive elements. These guys are the traffic cops of the circuit. They can manage energy, they can direct it, they can slow it down, but they can't create any new energy on their own.
And that's the absolute key takeaway right there. A passive element cannot, on its own, generate power. It can't just invent a voltage or push out a current from nothing. All it can do is react to the energy that's already in the system, by storing it, resisting it, or just letting it flow through. So, the big three you've probably heard of are resistors, which kind of act like the brakes on a car, controlling the flow. Then you have capacitors, which are like these tiny, super fast rechargeable batteries. And you have inductors. These are the essential managers, the administrators of the circuit. But remember, they are not the power plant.
Which brings us to the other side of the coin, the active elements. If the passive guys are the managers and the traffic cops, then these are the power plants themselves. This is where the energy is actually born.
Yeah, this is where the real action is. An active element is any component that can pump energy into the circuit. It's the source. It's what provides the kick, the voltage or the current that gets everything else moving in the first place.
And of course, you already know some of these. We're talking about things like giant power plant generators, or the simple battery in your TV remote. But it also includes more sophisticated things like operational amplifiers, which can take a tiny signal and make it huge. The one thing they all have in common? They add energy to the system.
Okay, but here's where it gets really cool. Just calling something an energy provider doesn't actually tell you the whole story. Because within this family of active elements, there's a super important distinction that really changes the game. We actually have to split them into two more groups, independent sources and dependent sources. And believe me, understanding this difference is the key to unlocking how really complex, smart circuits actually work.
So what's the difference? Well, an independent source is kind of dumb, in a good way. Think of a perfect battery. It just puts out its voltage day in and day out, no matter what. It's totally self-contained. A dependent source, on the other hand, now that is a smart power supply. Its output, whether it's voltage or current, is actually being controlled by a signal somewhere else in the circuit. It's like a power source that takes orders.
So how on earth do you tell these apart when you're looking at a circuit diagram? Well, thankfully, engineers came up with a really simple and, honestly, quite elegant visual code. Once you see it, you can't unsee it, and you'll be able to read circuits in a whole new way.
The first part of the code is just the shape. It's that simple. If you see a circle, you're looking at an independent source. It stands on its own. But if you see a diamond, bam, you're looking at a dependent source. That diamond shape is your clue that this thing's behavior is being controlled.
Now for part two of the code. What's drawn inside the shape? If you see a plus and minus sign, that means it's a voltage source. If you see an arrow, that tells you it's a current source, and it even shows you which way the current's going to flow. So, a circle with an arrow inside, that's an independent current source. A diamond with a plus and minus, you got it, a dependent voltage source. See, it's a simple two-part system.
So let's just hammer this home one more time. The second you see that diamond shape in a diagram, your brain should immediately think controlled. The power coming out of that component isn't fixed. It's changing based on orders it's getting from somewhere else in the circuit.
This brings us to the four specific types of these smart sources, and the best part is their names are basically instruction manuals. Let's take the first one, VCVS. That stands for Voltage Controlled Voltage Source. The name literally tells you that a voltage somewhere controls the voltage this source puts out. Or how about VCCS? That's a Voltage Controlled Current Source. A voltage is controlling a current. The logic is exactly the same for all four. It's a beautifully straightforward system.
So, the next time you peek at a circuit diagram, It's not going to be just a bunch of lines and squiggles. You'll see the power plants and the pipes. You'll see the steady, independent workhorses and the smart, responsive ones that are taking orders. You've just learned to read a new language.
Seriously, knowing this one distinction, active versus passive, independent versus dependent, it gives you this new lens to see the world. You can start to imagine that incredible invisible dance of energy and control happening inside every single device you touch. So I'll leave you with this. What will you see now?